This presentation is entitled Faith Lessons from Chaotic Fig Trees. Here it is shown how some recently discovered Feigenbaum trees, named after physicist Mitch Feigenbaum, provide relevant lessons for faith in consonance with what is written in the Bible. The thesis of this work is that we humans, with the gift of a soul, may learn from recent advances regarding natural complexity in order to find peace and build a better world. As may be easily verified, and to set connections to be clarified later, the fig tree is an important symbol in Holy Scripture. It appears first in the fall of Adam and Eve, in the way they covered their nakedness using fig leaves. Then, throughout the Old Testament, it is a consistent symbol, together with the vine, for the people of Israel. And such are seen in the good and bad times when they enjoy or lack such fruits. As the prophet Isaiah administered a poultice of figs to cure King Hezekiah, the fig also serves as a notorious healing symbol. In the New Testament, the first mention is in the story of Nathanael, a disciple who yielded to Jesus Christ only because he told him that he saw him under a fig tree. Such a symbolic tree also appears prominently in the odd and extensively criticized cursing and killing of a barren fig tree that, we are told, bore no fruit because it was not in season. Additionally, the fig tree is also mentioned in Jesus' eschatological discourse when he explains that such a tree with a tender branch and budding leaves would signal his return. The aim of this talk is to show how modern science, chaos theory in particular, provides suitable elements for us to further understand such passages in a way that calls us to love one another. Hailed as one of the most important scientific achievements of the 20th century, chaos theory provides poignant symbols and precise semantics. The prototypical equation used to illustrate a well-established theory is the logistic map. Xk plus 1 equals alpha xk times 1 minus xk. Here x may represent the size of a normalized population from 0 to 1 of, say, rabbits. K and k plus 1 are subsequent generations, and alpha is a parameter that may take values from 0 to 4. The logistic parabola, obtained by plotting one generation against the next, exhibits an increase if xk is small, but a decrease if it is large, as it is shown here for alpha equal to 0.8. Aided by the one-to-one line y equal to x, we may compute the sequence of iterations of the map, starting at a location x0 until it converges to its ultimate fate of the population x infinity. This x infinity depends, however, on alpha, as shall be summarized next. When the parabola is below the line y equal to x, as shown here, for alpha equals 0.7, the ultimate x infinity equals 0. Regardless of the initial population size, repeating the same dynamics leads to the same destination, the extinction of the rabbits. 0 is hence termed a stable attractor for the dynamics. When the parabola crosses the line and alpha is less than 3, x infinity is given by the non-zero intersection between the line and the parabola. Now, a small number of rabbits does not lead to their extinction, but rather to a constant population size. The origin, which previously attracted all the dynamics, now becomes a repeller when the line is crossed, and this happens as the slope of the parabola at the origin is too steep. But this is not all that may happen. When alpha exceeds 3, what happened to the origin also happens to the intersection between the line and the parabola. It no longer attracts, but rather repels the dynamics. As shown, for alpha equal to 3.2, the iterations do not settle at a single point, but instead oscillate indefinitely between two values, making up a square. And if alpha is further raised to 3.46, oscillations between two populations are no longer achievable, but instead, the dynamics settle into a repetitive pattern every 4 generations. In a surprising manner, This trend continues as alpha increases, and the logistic map defines increasing bifurcations that encompass all powers of 2 when the value of alpha reaches a limit in alpha infinity approximately equal to 3.5699. After alpha infinity, the dynamics may be either periodic or non-repetitive. As an example, when alpha equals 3.6 or 4, the iterations yield uncountable attractors, which are known as strange attractors due to their infiniteness. As such sets also have the property that nearby points end up diverging from one another, they are also known as chaotic. When alpha equals 3.74 or 3.83, the dynamics result in oscillations that repeat every 5 and 3 generations. Dramatically, there are such periodic oscillations after alpha infinity for any period not being a power of 2. At the end, the diagram of bifurcations, shaped as a tree when rotated 90 degrees counterclockwise, summarizes the incredible behavior of the deceptively simple logistic parabola. Notably, the diagram contains periodic behavior that encompasses all natural numbers and many non-repetitive behaviors, something impossible to foresee prior to the advent of modern computation. Here is observed in more detail the tail of the diagram. As is seen, strange attractors plotted as vertical collections of dots are very common after alpha infinity. Such periodic sets turn out to define dusty attractors as they do not cover all possibilities as indicated by distinct shades on the vertical lines. It also happens that in all white periodic bands, that is, in the buds of the tree, as in the notorious one by the middle and corresponding to period 3, one encounters small copies of the same tree. This fact reflects the exquisite fragmentation of the object that shows utter repetitions at diverse scales ad infinitum. The diagram of bifurcations includes also a multitude of thorns that corresponds to spiky distributions of dusty sets in the chaotic tree. The first one occurs precisely at alpha infinity, and such exhibits imbalances in the spikes and holes between them. Remarkably, there happen to be thorns galore by the ends of all white bands of buds, corresponding to the infinitely many periods encountered in the tail of the diagram. Believe it or not, the tree of bifurcation is also known as the Feigenbaum tree, or the fig tree in German, in honor of Mitch Feigenbaum, who proved for the first time some universal properties about the object. It happens that the bifurcations occur in an orderly manner, both in their openings and in their durations. As is seen here, the bifurcations cross the x bar equal 1/2 line in an alternating fashion, and the openings dis uben decrease such that the ratio from bifurcation to bifurcation tends to the number f1, the first Feigenbaum constant. Similarly, the duration of the bifurcations, delta sub n, decreases quickly, and the quotient from one bifurcation to the next tends to the number f2, the second Feigenbaum constant. These assertions show that there is order in the pathway of bifurcation that leads to chaos, but such does not imply, as often misaffirmed, that chaos itself is ordered and predictable. Feigenbaum's numbers are in fact universal, as they hold for countless equations that give rise to other chaotic trees. The iterations of functions with one peak, as the ones depicted here and related to the simple equations shown, always yield, by increasing alpha, a straight root, a tender branch, bifurcation branches, and, in an intertwined fashion, periodic branches and the dusty foliage of chaos, which then figuratively corresponds to fig leaves. In all cases, the openings and durations of bifurcations happen precisely at the speeds given by f1 and f2. These ideas turn out to be relevant in several fields, including biology, ecology, chemistry, physics, and economics. Among the most pertinent results are discoveries made and inspired by Albert Lichaber's work on how heating fluids leads to turbulence. Surprisingly, it turns out that alpha, at the very base of the second Feigenbaum constant, yields the heat that needs to be added to the fluid, whether liquid helium, mercury, or water, so that qualitative changes are observed. In order to further appreciate some of the subtleties of chaos, it is pertinent to study in some detail what takes place in the summit of chaos when alpha takes on its maximum value of 4. At such a maximum heat, the dynamics wander on a strange attractor that appear to encompass the entire interval from 0 to 1. However, this is not true, as unstable extensions of the Feigenbaum tree need to be excluded. For instance, the value of x equal to 3/4 and corresponding to the extension of the central tender branch cannot be in the ultimate attractor, for starting at such a value returns the same value forever, yielding a repetition with period 1 and not chaos. Values corresponding to any other period need also to be excluded, as save for those that repeat every 3 generations. As indicated in this diagram, not only do the 3 repeating values need to be excluded, but also all other points within the domain that are in the past of such values. Here k denotes a generation with 0 and positive values indicating eventual repetitions, and with negative values denoting points that are not yet on the periodic attractor. This diagram turns out to be easily computed, as there are 2 values in the past for any single value in the present. As such, the highest repeating value shown in generation 0 is associated with 2 preimages as found reading the parabola backwards, and such a process is repeated on each point, yielding a tree in powers of 2, a countable collection of points that hence cannot be part of the strange attractor. At the end, the strange attractor is indeed rather dusty, as it is equal to the whole interval from 0 to 1, minus the infinitely many trees like the one here, but corresponding to all the periods within the tree associated with any natural number. All this turns out to be very relevant because there is a collection of initial values that altogether escape the dreadful consequences of jumping forever, for such return dynamically, even if improbably, to the root of the tree. These are the preimages of 0 that find a way despite the most implacable heat, and that, by arriving precisely to the middle at generation 0, pass by 1 to finally rest at the origin. Notice how these observations reminds us of the concept of purgatory and the associated parable of the weeds. For the width in the preimages of 0 is finally surrounded by undesired behaviors that unfortunately end up forever in fire. Note how the ideas also reminds us of the 3 exalted friends of Prophet Daniel, dancing in the highest heat without consequences, and the protection of the prophet himself in the lion's den. For as the psalmist assures us, and as we may see geometrically, though 1,000 fall at your side, 10,000 at your right hand, near you it shall not come. This notion suggests, I think, some plain common sense reflections. For instance, they reaffirm that it is best to avoid chaos and its truly infernal turbulence, because missing the midpoint, even by a small distance epsilon, has, as shown, tragic consequences with all probability. The famous butterfly effect, expressing the incredible sensitivity of chaotic dynamics, does not provide us with good options at all, and instead leaves us irremediably trapped in an empty strange attractor in which, as some prophet has clearly explained, we may find no rest. As such, we may learn from these notions, and not only in relation to our rabbits, that it is best to come down the chaotic tree, just as the little man Zacchaeus did, and straighten out our errors, hence diminishing our intrinsic heats to find the straight root and accept God's salvation. As convergence to the root is associated with little parabolas that do not cross the line, these ideas also invite us to abandon ourselves to the chosen threshold, y equal to x, that is, to Jesus Christ himself, seen geometrically in the cross x and his crucified silhouette y, who we are told is the door and the narrow gate, and how narrow it is in the summit of heat, so that we may arrive to the love of the Father in the gentle state x infinity equal to 0, which consistently denotes the origin, now with a capital O. To say it yet in another way, the powerful symbols from chaos theory reminds us that it is best to move away from implicit nonlinearities that happen when alpha is greater than 1. For amplifying without proportion takes us into the shoot of the tree and eventually into dust, which represents death. And for, as clearly seen, people do not pick figs from thorn bushes. These ideas represent unexpected yet rather accurate connections between the geometric symbols and universal concepts of the science of chaos and Christian faith, providing an unforeseen invitation to reconciliation and love consistent with the very logistic of salvation. But the modern advent of the symbolic fig tree suggests even more. Could it be that the scientific Feigenbaum has a prophetic meaning? Could it be that we are being given a merciful clue that illuminates the ancient word via modern science? As we recall earlier, Jesus cursed an allegorical fruitless tree, and it consequently dried up to the root. Like the ancient one, the chaotic fig tree lacks any visible fruit. It contains instead leaves of dust that properly reminds us of the leaves Adam and Eve used to cover their shame. And as such, it is consistently cursed above the root by the inherent disobedience of crossing the threshold y equal to x. As the scripture hints that we may see it for ourselves, this fig tree and the other chaotic trees shown previously has a tender branch or branches and literally contains a multitude of bursting buds in its periodic bands. As the foliage in the trees symbolizes the way we progressively move away from the root of goodness, and as the trees also contain multitudes of equally symbolic thorns, it is sensible to ask ourselves, if we pay attention to Scripture, if these ideas are a preamble of a near summer, of a near return, as Jesus expressed it in his eschatological discourse. For in the bifurcations diagram, it may also be appreciated why the axe lies at the root of the trees, as expressed by John the Baptist. Why it makes sense that the root is the logical location where Jesus saw the future apostle Nathanael, that is, under the fig tree, and why Jesus said to his astonished disciples that they could also curse the fig tree, no doubt in the same way that he rebuked the wind, whose ruler, the devil, is potently symbolized by the ratio 2/3 equals 0.666, as found by the end of the first bent branch. Although by divine design, the notions herein and other ancient signs do not allow us to set exact dates, they help us sketch some options we have that heighten the goodness of behaving properly in preparation for a triumphant return. Such options are order or disorder, simplicity or complexity, serenity or turbulence, peace or chaos, decreasing or increasing, following God's way below y equal to x, or choosing our way above y equal to x, abandonment or selfishness, obedience or rebelliousness, to receiving consequence, blessings or curses, and ultimately to rest eternally in heaven or to wander forever in hell. To summarize this talk, I would like to share a slice of a poem called in German Feigenbaum's Parable, or the Parable of the Fig Tree. Foliage of disordered, trapped in empty dust, jumps astir forever, enduring subtle trust. Crossing of the outset, leaving faithful root, looming tender offset, failing to yield fruit. Cascade of bifurcations, increasing heat within, inescapable succession of branches bent by wind. The sprouting of dynamics attracted to the strange, or infinity reminding at the origin the flame. Could it be, oh my friends, that science offers a rhyme? For a rotten tree foretells the very advent of time. Could it be, oh how plain, that nature extends a call? For all parable proclaims the crux in growing small. Thank you very much for listening. For additional information, the interested audience is referred to the book, The Fig Tree and the Bell.